So thank you everyone for coming today here, especially today that's a rainy day, one of them rare raining days in Athens. It makes it a bit more difficult, but you're here. Thank you very much. Can I see how many of you come here for the first time in the Docker Athens meetup? Okay, great. Welcome to this meetup. And as Antoni said, we would love to have you have a presentation here. Just reach out with an email and yeah, we can make this happen. So what are we going to talk about today is what we call very descriptively pull request review deployments with Docker, which is one of the techniques we have started building up in the company for the last year, maybe 18 months, and we're doing step by step. We're actually doing incremental steps, and we've come to a point that we're really happy with what we've built, and we really couldn't wait to share it with you. So that was the whole concept, like staging environments are so 2024, and the new fresh thing is pull request deployments. So this is it, and what we're going to talk about today in a bit more details is what is this that we call pull request review deployments, why this is important for us, and how we build it end to end. So especially in the how part, this is where we're going to get into lots of details about what we're doing. It's not going to get too deep on each particular part of that process, but because there are many different parts to make this a complete workflow, we're going to talk about a lot of things. So let's start with what are pull request deployments? What we do is we deploy every pull request on its own dedicated environment. So in a nutshell, when we open up a new pull request, a new deployment happens automatically, and we get a URL where we can preview the work that we're doing in this particular branch. And there is no centralized deployment environment, like a centralized staging environment, nothing like that. It's just the pull request deployments and the production deployment. There is one exception, though, I have to say that in one of the examples that we're going to show here, there is a staging environment, but it's mainly because we don't have a production environment yet. It's because it's about to be launched soon. And this is mainly a Git and GitHub-based workflow that works with events like pushing new commits, commenting on a pull request to trigger some events and stuff like that. So this is the whole concept. We have every pull request has its own deployment, and there's nothing centralized there. This is visually an example of how you can see this working. So here's one of the people in the team that's pushing one commit. The tests pass. Maybe it's not visible, but we have a green check mark here, and then we can see below that Evelina deployed this branch using GitHub Actions, and there's a UI button in GitHub to view that deployment. Another example here is that we're making a comment which is .recreate, and for example, we recreate an environment from scratch in case something went real south as we were testing some stuff. But the next question after we discuss about what are those pull request deployments is why? Why would we do that thing? Why not use a staging environment? And the main thing, if I can say that in a nutshell before diving into the slide, is that it gives us much more autonomy. It makes things much faster for us. It's much simpler compared to having a staging environment. And the main reason for that is that we don't have to do anything other than create the pull request, and then we have a prepared environment where we can check out our work and share that. We don't have to take into account work that's being done by the rest of the team on other branches, and because we have an isolated environment there, and there's no conflict. We don't have to coordinate with the rest of the team that, are you using the staging branch, the staging environment? Did you do any migrations there? Do I have to do something else? No one causes any issue to anyone as we work with this way. So we have much less friction, and we have much more time to do meaningful work. And To get into a bit more detail, why not a staging environment? This is, let's say, one-to-one comparison. The first one is that a staging environment, because it's centralized, it requires some sort of coordination with the team. Now we can work completely autonomously. The database is not fragile because each environment has its own database with its own migrations, its own schema. So no change in no code in any branch can in any way affect the database of any other branch, which is really important. And usually staging environments are built for internal consumption. So if you want to have something that you can share with some shareholders, usually you add another environment, which is an additional step of complexity, because you still, you have to do some sort of coordination in the QA environment and stuff like that. We don't have to do this with the pull request deployments. We can share, each one is isolated, we can share it with someone. And if we really want to have something completely separate, we can just create a new branch from the same commit, and we're going to get a copy of that environment and share this with a client if we want to keep the other one for internal use. So it's much less friction. And this is the what and the why. What do we call pull request deployments, and why this is important for us? Because autonomy is important. We don't want friction. We just want to do our work and enjoy it and be efficient and productive. And now we're going to see how did we implement this in our case. And this is it. As I told you, we're going to talk about lots of stuff. We're not going to get quite deep into each one of those subjects, but first we're gonna see the infrastructure of this setup. Then we're gonna see the Docker configuration that we have. Then the CI/CD, how we do observability or O11Y, if you want to be one of those cool kids these days. Then we're going to see how we are initializing those environments with data, because this is real important, and we're going to see why. How we manage subdomains and SSL certificates for all of those environments, because they're actual deployments. And finally, how we manage access control, because we do not want anyone to have access to those environments. So lots of stuff. We're not going to get quite deep into each one of those, but we're going to see the whole picture of it. And hopefully in one of the next meetups, we're going to start, if there's a slot and we don't have any other speakers, you're going to see us getting deeper into all of those, subjects. So first, infrastructure. I'm not sure what we're expecting here, but this is really the simplest part of the whole thing. So we have, I think, in my opinion, the simplest infrastructure that we can. So we have one bare metal server. It's not a beast, but it's a real, maybe, I'm not sure, maybe it's at least 64 gigabytes of RAM, maybe it's 124, but it's a big one, so it can host multiple environments. Right now, I think we have tens of deployments on that server. Each one of those has web servers, workers, queues, Redis, databases. So they're quite big stuff, stacks, and we have tens of them. And we have Cloudflare on top of the bare metal server to make sure that our web services are being accessed in the proper way. And our bare metal server has three components on it that help us make the work. So first one is the self-hosted GitHub Actions runner, which is, we're going to see next why we picked this option. Then we're using Docker Swarm, which is, let's say, it's Docker's lightweight version of Kubernetes, which helps us a lot with setting up things. So Docker Swarm is our choice, but this could be Kubernetes in your choice. It could be plain Docker if you don't want some of the features that we want, but it just means you need a container runtime so you can run your services. And then we have Cyrix, which is something we've built here, and it's open source, and we'll get into details in another presentation, but we're going to give you a sneak peek. And then we have Cloudflare, which is on top, and we're using DNS with proxy configuration. So Cloudflare proxies to our server. It's not a simple DNS resolving. And we're using Cloudflare Access to see the access control later. So if we can make this a diagram, it's, as I said, it's real simple. We have Cloudflare, this is where the users get, access. This is how our users, which is us actually, and our stakeholders access these review environments. We have Cloudflare access along with the proxy mode, and then this connects with HTTP and HTTPS with our bare metal server, and which runs Docker Swarm, which runs Cyrix. We're gonna talk just a little bit about it, and then the GitHub Actions self-hosted runner. It's a bit blurred, by the way, but we're gonna upload the slides later. So if you don't see well what's written here, you're gonna see it online afterwards. I think it doesn't get simpler. We just have two components. We have the CDN in front and the bare metal server, just one bare metal server. And the reason we kept that very simple setup is because this is a development environment. This is something that we can just throw away and no user data is there. Nothing really important or precious or valuable is on that server. So we keep it as simple as possible. We saw the infrastructure. Now we're gonna take a look at the Docker configuration, which is also a bit simple, not quite complex, but it has to follow a few principles so that it works seamlessly in that context. So first of all, it's important to be able to build Docker images with a single command. Just a single command to build all of the Docker images that you need. Usually you would just need one, but maybe you have a project that needs that has multiple components and stuff like that. So it should be really easy to build it with one single command, because the more configuration you need and the more components that you have, the more difficult it gets to make this deployable on multiple environments. We'll see in a bit how we achieve this. Then you need to be able to deploy the containers with a single command, because the more steps you need to take, the more things can go wrong from one step to another. And this is one of the reasons that we picked Docker Swarm, because we have one command to deploy the whole stack, and then Docker Swarm takes care of getting all containers to the desired state and everything that we need. And finally, the Docker configuration needs to be configurable according to the environment. So you need to give it the parameters required to know that it's running on an environment A or B or C, or anyway, we're gonna see that. So yeah, I guess you cannot see anything here. Let me see if I can zoom. Nah. Okay. Oh no. Doesn't work. Let's give it another go. Okay. So as you might see, so it's cropped, but I'm gonna tell you it's a compose.swarm.yml file. This is how we name our files for Docker Swarm. And we have our services here. So this is actually quite simplified. We have erased lots of configuration to get it fit into this screen. Wasn't enough, turns out, but we're gonna do the work. So we have our services here. Every service has a build attribute, so that it has the configuration that it needs, so that we know how to build the service. This is very simple. We're just saying, build this directory, but you can have more complex stuff. We also have the image tag here, so that we know inside the Swarm file what's the output, or the desired output image tag for this particular service. Here we have an option to give it a tag according to the Git commit. So depending on which Git commit we're running, this is going to build a separate tag. Also here we pass an environment variable, for example, that says what is this environment that I'm running in? And we're gonna see in a bit how we're using this inside the application. We have our secrets here, we have our networks. We're exposing our services in two networks. One is the internal network of Docker Swarm, and which is not important right now, but the most important is that we make this service available to Cyrix, which is another component that we talked about and we're gonna see in a bit. We'll have our volumes and stuff. But as we can see, this is one single configuration, one Swarm file that we can use to build all images publish our images, deploy all of our services. We have one single configuration where we control everything. This makes it really easy to deploy across multiple environments. It's the same thing. Now let's see. Okay. And this is how we do Docker. We have our Docker file. I didn't show this because it's just a Docker file, nothing special there. But we have a compose file that builds and deploys all services with one command. Then we're going to see the CI/CD, how we're doing this part of the deployment. What are the principles that we're following for those preview environments? So 3 things that are real important here. First one is that we're using self-hosted runners, and we're going to see in a bit why we're doing this. Then we're using reusable workflows. This is a feature of GitHub Actions, and it's really important for us, and I'll say why in a bit. And finally, we have multiple deployment triggers. We are deploying these environments every time we create or update a pull request, and we can also trigger deployments on demand with a comment on each pull request. Both of those workflows are real important. And now we're going to see why we picked each one of those choices. So why self-hosted runners? The first reason is that we found out that deployments building on GitHub hosted runners was usually slower because it needed to initialize the runner every time. Then it needed to, even if we had great Docker image layer caching, it needed to pull it through the network from the GitHub Actions cache service. And the other one is because we can get really nerdy with cache, we could not use the cache mounts in builds, which is a bit of a, let's say, it's a bit of a deep cut feature of Docker files, which give you another layer of caching. We're not going to talk about it right now. I think we've done in the past. But anyway, this does not work on GitHub hosted runners. And with self-hosted runners, we have all the cache layers on the machine. It's huge, it's fast, it's incredible. We don't wait. And the other one is that we have local secure connection with Docker Swarm. If you want to connect with the Docker engine from a remote machine, you need to set up, you need to set up a secure connection, which is usually done with mutual TLS, and you need to manage that thing. So we are not that fond of this workflow. And self-hosted runners, because they're running on the machine, make it very simple for us to do those deployments. Then is why we picked reusable workflows. And this is because with reusable GitHub Actions workflows, we have one way to deploy everything. There's one workflow file that we call no matter what is the trigger event, and we get the same result. And this means that whether we are pushing a new commit to a Git branch or whether we're commenting on a pull request, we can have the exact same parameters with just a few lines of code to deploy that particular environment. So this makes it really easy to have more versatile workflows. And the reason we need multiple triggers, so why not just have git push, or why not just have comments? So deploying automatically when we push a new commit or when we open up a new pull request makes things faster. We have to do less things. We open the pull request, we get the URL, it's there, done. But sometimes we might have done something wrong with the migrations. We might have messed up with the data on the database. And now this environment is not usable. We cannot use it. So we need to do a new deployment. We need to start from scratch. And this is why we use comments. So for example, if we completely ruin, we savage an environment, we just type .recreate on the GitHub pull request, and this is going to wipe everything up, volumes, networks, Docker containers, everything. It's going to wipe everything up, and it's going to start from the beginning, which really reduces the need for someone else to say, hey, can you fix my environment? I did some things wrong. No problem. .recreate, everything is done. So again, this is not quite visible here. I will try to hack this. Okay. So for example, here we have a job named deploy preview, and we say, if the event is pull request, use this reusable workflow with those parameters. It's just, I know there are a lot, but it's just, 10 parameters, flat structure. Not many things can be done wrong. Maybe we could do more DRY, but this is good for now. And when we comment on a pull request, it's not quite different. We have a filter here that we say, trigger this event when we have a new issue comment, because this is how it's a pull request comment. And we say, when the command is .recreate, we're using an open source action from provided by GitHub to do this. As I told you, I'm not gonna get into quite lots of details into each one of these parts. We can discuss it later, but we're gonna see the whole range. So when we comment with .recreate, this is a requirement to clean up the stack. Again, I have removed some stuff here to get it fitting into the screen, but you can get the point. And then we have the finally the deploy preview, again, job that reuses the same workflow as before, and we pass the correct parameters. So what's happening here is that we have three jobs. We have the deploy preview that it needs the cleanup job to run, and we have the cleanup job that needs the recreate trigger to run and requires the output to encourage to continue working, which happens only when we write .recreate. So what happens is when we type .recreate in an issue comment, this trigger is gonna run, this job is gonna run, which is gonna trigger then cleanup and then the preview. So the most important part that I wanted to show you here is that finally the part of the CI/CD that deploys the preview environment is almost the same, regardless of whether that's happening because of a comment on a pull request or because we pushed a commit. Because we don't love configuring stuff all the time, and so we want to write the less code possible. And now I'm gonna get into your stuff. You can roast me. So this is the point where we're gonna talk about observability. One very important thing when we deploy anything, whether that's production, whether that's development, is being able to see what the hell is happening there. Make it easy to understand whether our deployment succeeded, if anything's go wrong, what goes right, have get the whole view on that. And for us, we see three things that are important for us. The first one is the deployment status. Make it very, very easy to see if everything succeeded. Then error tracking. Make it easy to see what's going wrong. And finally, see the logs, see what's happening on it, because everything might be going well, but you might need to see some details that you have in the code, some events that might be triggered, whatever, So we're gonna see what we're doing in each one of these. The first one is the deployment status. This is the easiest thing out of all, because deployments are a feature in GitHub. So when you put some attributes in your workflow files, it's gonna populate some URLs and some deployment statuses on the UI of GitHub. So there's not much to do there, but it's really, really easy to track the deployment status in GitHub. So you can see in each pull request if it's succeeded. It also has a centralized view where you can see all your deployments across environments. Great thing. Also, you can go to GitHub Actions to see details about how each job went, and you can also subscribe to deployment status updates using external tools. So if you have the GitHub app in your Slack workspace, you can do that /GitHub subscribe thing and say, I want to know the deployments on this repository, and you can have a feed of those deployments in your Slack channel. You can do all sorts of stuff. And this is how it looks. For example, here, again, I'm not gonna zoom, I'm gonna say to you. For example, here we have some successful deployments that are now gray because we have new ones that have taken place after those. Here we have some deployments that have failed. And if you click on here, you can also see, I think it has an option to see what went wrong in the GitHub Actions level, why these deployments failed. Then we're going to talk about error tracking. We are using Sentry, which is a tool for error tracking. It tracks exceptions. A very important thing for us with Sentry and why we're using it is because we can filter errors according to the release we did, which is based on the Git commit that we released, the environment where we released, but most importantly, because we're Python developers, it integrates with Django, and which is the framework that we're using 99% of the time, and we can see the whole exception stack. So when something goes wrong, we can see the values of its variable when the exception was raised, and we can see this across the whole stack trace. Very helpful. So again, you're going to see this online later, but I'm going to say to you, this is the view of Sentry, which is here. We can see the release. This is the commit SHA, and this is the environment, which is PR does the number of the pull requests that we deployed. And this makes it real easy for us to go and filter according to the environment, to whatever. And then we have the logs. How do we see what's going on in its service? We're using a very simple tool. It's called Dozzle, and you deploy it on your Docker runtime. We're deploying it on Swarm, and it's a very simple container log monitoring. And what we're doing is that on every successful deployment, we're posting a comment on our pull requests with a link with the appropriate filters to go to Dozzle and see the logs of this deployment. So here, as you can see, we did a deployment, everything went well, and now we have a comment that says, you know, logs are available here. So when we click that link, we go to Dozzle and we can see the logs of this particular deployment, which looks like this. It has that URL here, okay? And here is the container that you can pick to see every time, and here you see the logs. So you can also search in the logs. It's a very simple tool, not many features, not TLK, but does the job most of the time. And now that we saw what we're doing with observability, we're gonna move to data, how we initialize those deployments with data, which again is something that helped us a lot, because first, when we started with pull request environments, we were not, publishing any data on it, which made them a bit useless, because we needed to SSH into the server and do some stuff manually, or do some other stuff. But now we don't have to do so, and I'm going to tell you why. And this is, there are three things, essentially two, but there are three things that we need to do in every pull request after it gets deployed. We need to publish sample data, and then we need to create users, sample users that can interact with each other. And then we need a super user that can further manage the platform and add some more data or stuff like that. Now, the reason that I'm saying sample users on top of sample data is we were working on an application a while ago, which is a marketplace that had multiple types of users. So it had customers, it had professionals, and in order to test the workflows easily, you needed to go and sign up with multiple roles. You need to go and sign up as a customer, then you needed to go and sign up as a professional, and this was taking quite a lot of time to do it every time. So creating the appropriate users as well is a really important thing. It's part of initializing it with data, but I wanted to emphasize that users are important as well. The way we're doing this in Django is that we're generating fixtures from our local environment. When we say, okay, we need to create the setup for the environments, at some point we generate some fixtures. This is how they're called, with a command named dump data. which what it does is it outputs the database, your database in a JSON format that you can then load later. We go by hand and we clean up those data. We might remove something that we do not want to be checked out in Git, let's say some personal, information and stuff like that. And after we make sure that our fixtures, they're cleaned up, we check them out in Git. And then we load them and initialize the super user in the entry point of the Docker image, which means that the first thing that runs before any command that runs in our deployment is the initialization of these data. By the way, this manual thing needs to be done by hand, I think. Maybe we can automate it with AI at some point. But anyway, we're doing this by hand, and it's usually done 1 or 2 times in a project's lifetime. So it's not something that takes quite a lot of time. And here I'm going to zoom into our entry point. This is how it looks. So we have some database checks first, and then we have environment variables that we use to control whether each one of those steps are happening. So for example, we have an environment variable to skip the migration part, which is the part that creates the database and the tables and all that stuff. We have an environment variable that we're using to say, you need to create a root user for this application. And we have a default password that we set. We do not care that the super user has a guessable password. Right now, I did the Docker Athens password here, because these are temporary environments. They don't have anything sensitive in there, and they are protected also. So we just create the super user here, and then we load the data that we have in checked out in our code base. And we might also have some media features, which might be some profile pictures and stuff like that, checked out as well. And we copy them in the appropriate URL. So, for example, when we run an application that has a web server and a worker, usually we will run everything on the web server, but the worker will not run any migrations or features or stuff like that, because we do not want to have any race conditions among multiple services of the same code base. Moving on, it's not the last segment yet, but as we're moving closer to the end, we're going to talk about subdomains and SSL certificates. As we said before, every deployment, every pull request gets its own URL. It's unique, and it needs to be secure. So everything is accessed exclusively through SSL. How do we make this work? I just said that, so I'm going to move to the next slide. So for subdomains, we're using Sirix, which is an open source project that we started in our first startup with Antonis. And it's a dynamic reverse proxy based on Nginx. And it's configurable through an HTTP API. This means that we can curl this server and add a subdomain and a target. It's open source. We started it in our previous company. Now we are maintaining it in Logic, and we are working on some great things on this open source project, and we hope to share them with you soon. The way it looks in GitHub Action is like that. It's gonna change the slide. So the zooming does not help, but all we do is, after we deploy the Docker stack successfully, we're running this command, which is a curl post request with a JSON payload that says, the source is the domain. The domain is being set in GitHub Actions. It's just an environment variable that has PR does the PR number dot project name dot with logic.work, which is the domain name that we use for our own projects internally. And then we have a target, which is the second member of the JSON object, which is HTTP, the stack name. It's since we're using Docker Swarm, we're using stacks. It's a stack name _web. We have this convention internally. Every web service is called web in our compose files, as you may have seen before. And then we are enforcing HTTPS connection externally. So this is it. It's pretty simple JSON payload, and we are triggering the Sirix container locally in API/routes. You can see how that works. It's open source. So the last part of the workflow is say, take this subdomain and route it to this container locally internally. By the way, for this to work, we have added a DNS record like, star.withlogic.work, send this to the server. So we know that all these domains end up on our bare metal server. And finally, we're using Cloudflare for SSL certificates. So we have Cloudflare in front, which is proxying all requests back to our bare metal server. And we're having Cloudflare issue the SSL certificates. And we also have a trust relationship with the root certificates of Cloudflare on our own server. So what happens is that when the user connects with Cloudflare, it does the HTTP/HTTPS negotiation there. So if you're accessing through HTTP, Cloudflare is going to take care of redirecting you back to HTTPS, issuing the new certificate and all that stuff. And then Cloudflare is going to talk to Sirix over HTTPS to our server. Although we're listening both to 80 and 443, and if for any reason Cloudflare talks with over simple HTTP, we're going to redirect it in case, for example, we configured it wrong at some point. And after all those stuff, we're going to get to the last point of this presentation, which is access control. So we do not want all of those stuff to be accessed by everyone. They might not have sensitive data on it, hopefully. At least I have not entered any. But we do not want anyone to be able to go and preview what we're building for our products or for our clients' products, and we want to control everything. So with previous clients that we've worked in the past, we've seen base authentication stuff in it, or some front-end authentication stuff, which is gross. And we wanted to do something good here. And we found out that we did not want to spend lots of time on configuring things, because the more complex the configuration is, the more easy it is for it to break down or do mistakes. And we wanted to use our own SSO if possible, because we do not want to manage multiple credentials. Because if we manage multiple credentials, if someone loses their credentials, they might need to get in touch with us, and none of it. And we found out about Cloudflare Access, which is a service that Cloudflare provides when you're using this proxy mode that we talked before. And it allows you to have multiple access groups on its target and multiple identity providers. So for example, when we are working with clients, the preview deployments allow our clients to get access to those environments after authenticating with their email address. But we, inside the company, we need to authenticate with our Google Workspace accounts, for example. So this makes it very easy for us to connect. We don't have to manage anything. And our clients just have to have access to their email address. And I changed the slide, but this is stuck here. Okay. Yeah, and this is how it works. You go to the page, and then you see this screen that says, either enter your email or sign in with Google. And this is how we protect all of those environments, and they're not accessible from anyone. And yeah, it's a wrap. This is it pretty much. If I have to say three things about what's important for us, is we need isolated environments. No one needs to mess with anyone. We just deploy the thing. We cannot destroy anything of another person working on the same project. No one can mess with our work. We can see what's going wrong. It's easy for us to see what exceptions are being raised, the logs in our applications, if our deployments are being successful or not. And we can easily control who gets access to what, which client to which application, and in general, who gets access to what. This is it. Thank you very much for spending the time with me. Thank you. And finally, I want to share that mainly the examples that I showed to you are from a project called Party that we've been working with lately with some great people. And over there, and the team at Counterparty is hiring right now. There are no developer jobs open, but there will be quite soon. So go to linkedin.com/company/Counterparty and make sure to follow that page, because there are going to be some announcements soon. And thank you very much. I'd love to hear your questions. If they're in English, great. If they're in Greek, great. I'm just going to translate them, the response in English as well. And yeah, let's go. Does anyone have any question? I did not order the pizzas. Oh, no. Yeah, so we're going to have some pizzas later. Yeah?
So have you thought what are you going to do with this? To have like a snapshot of the database to be environment.
Yeah.
Because at some point initialization wouldn't be enough, right? You need some live data from what's in production. Have you thought about it? Yeah.
So I think I have a couple of answers for this. So the first one is, and actually I was thinking about this as I was doing the presentation, and it was a background process. And I think it's important in the future to add some sort of terminal access to, and I'll tell you why this is has to do with what you're talking about in these containers, because in case we have an environment that we bring it to a state that the data is useful, it needs to be easy to pull this data from that environment. And maybe if we have a terminal and go there, we can go and dump data, download them, and update the fixtures in the repository. So another thing that you're talking about is we had this conversation with Antonis a few minutes before we left the office today, which is why it's important sometimes to snapshot the data from an existing database. So this is a good point, actually. Right now, if we need to do this and we had a centralized environment to copy the data, I guess this would be a command. How would we do this? Okay, the way that we would do this in my mind right now, which I think is a very valid point, is copying the volume data from another volume on that server. But to complete the answer on what you talked about, getting data from production is always the best thing. But I guess this should be done in a way that first pulls the data from production, anonymizes everything, and then puts it in a central place where you need a pipeline. But the way I'm thinking about this is maybe it would need to be a parallel pipeline. Let's say once per week, you pull production, you anonymize the data, and then you put the fixtures in a central place. Great idea. We might do this soon, I guess, after we launch some things in production. Yes?
So as I have it in mind, the main thing, the main reason that we have a staging environment is to have something like mirrored with the production one.
Mm-hmm.
What are the key differences of these environments with the production?
Mm-hmm. So thank you. I'm replaying the question for the microphone. So usually you're having a staging environment to be as close as possible to the production environment. And what are the differences here with the production environment? Is this the question? Okay, great. So yes, this is why usually you need a staging environment. Here, it depends on the project, and I'm going to expand a bit on it. So a few of our clients are on bare metal servers. In this case, the differences are not a lot because the setup is quite much the same. In these cases, what would be the biggest difference is that even, for example, we have a client that we deployed everything using Docker Swarm and all that nice stuff, but it's on an EC2 instance, so we can use RDS as a database because it's managed and it was easier. I mean, they felt better with that option because we always let them know the full spectrum. We go from full bare metal to full managed. So the more managed you go, the more are the differences. So the less managed you go, the less are the differences. We always run everything on Docker, but until now, we have not run into any particular edge case that might be an issue. And I guess the reason that we do not have run into any trouble with these differences is because we have everything running in Docker all the time, from local development to production. But I'm trying to remember if we ever had a problem with RDS compared with how we connect to the Postgres container. But no, we're good. But the main difference is this: the more managed you go, the more the difference is. We have a client that's full on Fargate, which is a serverless option on AWS. This is quite a different runtime. So in this case, in production, we also have different configuration because it doesn't use the same configuration format. And this is where we have to do some more work when, for example, we add a new environment variable. But most of the times, we don't have to do many things, and we have not run into any trouble with the differences they have. Quite big of an answer, but I hope. Did I answer? Yeah.
Because if you have to break this topic, you usually start with the logout thing, then you go to the scroll file that's almost the same, but not exactly. And then you say, okay, I did everything. And then you have the third one, and then usually you forget the other one. And especially in those cases, you might have your configuration in a separate repository with for whole infrastructure. So this might become even more tricky, because the good thing about having Kubernetes manifests, Swapper, all those things, are that everything is contained in a single repository. One, in cases where you have a mix of an infra repository and the cloud pipeline, then you have to configure two things.
I'm going to replay the answer, just a bit shorter for the video. So the issue is that the more configuration you have, which happens when you have more differences from those environments to production, the easier it is to forget to do something, which is especially true, for example, when you have also an additional repository where you manage your infrastructure with Terraform, and maybe this is where you create the task definitions for Fargate, and you also need to update the Fargate definitions in the repository with the code, but you also have Docker Compose Swarm for the preview environments and Docker Compose, which is different for your local environments. Yeah. Any other question? Yes?
Did you face any challenges when integrating with?
Yeah. So I had a bullet point to add about this, and I'm gonna talk about this as well. I forgot to consult with Antonis before, so I wiped it out. And the question is, if we had any challenges with integrating with external services. This is true especially when you have to do OAuth sign-in into the application. So depending on the OAuth provider, this might be either difficult or almost impossible without an additional service. So if you have an OAuth provider that allows you to use asterisk subdomain, this is quite easy. I think Google does that because no. So Google does not does that. Something else, another provider. So as you can imagine, I'm not the one that wrote that code, but it depends. It depends on the service. What in my mind, I was really thinking about this, but what I would do is I would create an intermediate service that would act as the authentication, let's say, central place for all preview environments, and have it somehow delegate access to its preview environment. So yeah, I guess we're not implementing it right now. This is not something that can be resolved easily, for sure. Any other question? I think we're good. Thank you.